In this training program, you will learn about the Kumi Hydraulic Subsea Blowout Preventer Control System, its component parts, principle of operation, and some basic tips on maintenance. Naturally, the information you receive from this training program will not make you fully qualified to operate this unit. Your supervisor will be giving you additional training you will need later. What you will learn today, however, will make you familiar with the Blowout Preventer Control System operations and help you learn the additional training much faster. This program is not intended to replace the Subsea manual and complete reference guide. This manual will become your Bible on the operation of the BOP unit. Always refer to this manual anytime you have a question about the Blowout Preventer Control System or its operation and maintenance. You have been given a workbook which looks like this. This workbook will be used several times during this program, so keep it and a pencil near you while you watch the television screen. When we want you to use the workbook, you will see this sign on the screen. When you use the workbook, it will be necessary for you to stop the playback unit. To do this, you press the pause key on the playback unit when you hear a tone like this. Be sure you press the pause key only when you hear the tone. To restart the playback unit, you press the pause key again. This allows the program to continue. Now, open your workbook to page 1. There you will see the objectives listed for this program. This list of objectives tells you exactly what you will learn in this program and exactly how you will be tested to see if you have learned it. By reading this list, you can make certain you haven't missed something important. We will also have a test for you at the end of this training program. Our test will not be tricky or hard, but it will include the items listed in the objectives on page 1. If it says you should be able to identify, define, or explain, that is exactly what we mean, and that is what you will be asked to do on the test. These are important performance objectives, things that someone can observe you do and judge if you are correct or not. Also, you will be able to tell exactly how you are succeeding at all times. As we go along, we will present information to you and give you a chance to check your understanding of it. This self-check will also let you practice doing what the training objectives call for. Now, let's continue with the program. The Kumi Hydraulic Subsea Blowout Preventer Control System, or BOP system, as we will refer to it from now on, is the equipment used for remote control of the subsea BOP stack and related equipment. The equipment which makes up this system has been engineered and designed to control the preventers quickly under blowout conditions. All of the vital surface components are located away from the danger area, and the controls for operating the system are at the driller's location for immediate action, with auxiliary controls located away from the drilling area. Before we go any farther, you should become familiar with the various component parts that make up a BOP unit. Turn to page 2 in your workbook. There you will see a drawing of a standard hydraulic BOP control system setup and an equipment list. When you hear the tone, press the pause key to stop the playback unit. Study the drawing and list of equipment carefully. When you are familiar with the name of each piece of equipment, press the pause key and start the playback unit again. Ready? Press the pause key when you hear the tone. Now that you have familiarized yourself with the name of the various pieces of equipment that make up the BOP, let's learn a little more about them. The heart of the BOP system is the Kumi accumulator unit and hydraulic control manifold. The accumulator unit is the central reserve power or storage unit for the pressurized hydraulic fluid that is required to operate the subsea stack. Accumulator bottles are one-piece steel cylinders which are normally skid-mounted along with the control manifold. These accumulator bottles can be mounted separately from the control manifold and frequently are when lack of space is a problem. The accumulator bottles are pre-charged at the factory with 1,000 psi of nitrogen. Prior to initial charging with hydraulic fluid, the cylinders should be checked to ensure that each one has the proper 1,000 psi pre-charge. If you find it necessary to recharge a cylinder with nitrogen, refer to the Subsea manual for the correct procedure. Always be certain that the manifold bleed valve on the accumulator units is open when pre-charging with nitrogen. After pre-charging the accumulator, be certain that you close this valve. Under normal operating conditions, the hydraulic fluid is stored in the accumulators at 3,000 psi. The accumulator bottles are kept under constant charge by an electrically operated triplex hydraulic pump, or, in the event of a power failure, by auxiliary air pumps. These pumps automatically come on when the pressure in the accumulators drops below 2,600 psi. The pressure switches in these pumps are preset at the factory and should not be changed except by a qualified technician that is familiar with the system. The hydraulic fluid that is used in this system must be mixed with water before it is put into the accumulators. Most Kumi units have an automatic mixing system. This mixing system automatically pulls the concentrated fluid from a storage tank, mixes it with the correct amount of water, and dumps it into the pump suction end of the reservoir tank ready for use. From the suction end of the reservoir tank, the pumps pick the fluid up and keep a continuous fluid charge in the accumulators. There is a fluid level sight gauge on each tank that should be checked periodically to ensure that there is an adequate supply of hydraulic fluid. It is very important that fluid be kept in these tanks at all times. All Kumi hydraulic fluids are non-polluting, biodegradable, and disperse readily in salt water. In addition, they are mixable with ethylene glycol for use in cold climates. Since it is necessary for the hydraulic fluid to be cleaned and free of foreign material, there are two filter systems that should be cleaned on a regular basis. The first is on the suction line of each pump and is used to remove large particles of foreign material from the fluid before it actually reaches the pump. The second filter, which you see here, is on the discharge side of the pump and is a fine filter used to remove very small particles of foreign material which might not have been caught by the first filter. As noted, both of these filters should be checked and cleaned on a regular basis according to the Subsea manual. Unless you are working on the accumulator unit, there are several valves that must always be left in the on or open position. These are the shut-off valve between the accumulators and the hydraulic control manifold, the suction valve to the pumps, and the air valve to the air motors. If you have to close one of these valves during maintenance, be certain that you reopen it again when you are finished. It is very important that these valves remain open at all times to ensure proper operation of the unit. The hydraulic control manifold on the accumulator unit is where all of the hydraulic pilot control signals originate. These hydraulic pilot signals are sent via the interconnecting hose bundles to each of the Kumi control pods on the BOP stack. The hydraulic control manifold is normally mounted along with the accumulator unit. However, it can be skid-mounted separately. The components of this unit include 2 explosion-proof electrical junction boxes, gauges for readouts on all vital pressures, 3 increase-decrease regulator stations for regulation of pressures of certain functions, such as the annular BOP, the manifold BOP, and the ball joint. The 1-inch selector valve for selecting either one of the 2 control pods to operate the BOP stack. A flow meter which reads the volume of hydraulic fluid flowing from the surface accumulators to the BOP stack. 2 pilot pressure supply accumulators. 2 RBQ junction boxes for connecting the accumulator unit with the hydraulic jumper hose. And 2 types of hydraulic control valves for operating the various functions of the BOP stack. In addition to the manual hydraulic controls, there are 2 remote control panels. An electric driller's control panel, which is located at the driller's position on the rig floor, and an electric mini remote panel, which is normally located away from the drilling area, usually in the tool pusher's office. The driller's control panel, which is operated by the driller, allows complete operation of all of the functions of the hydraulic control manifold. This control panel contains an identical set of gauges and readouts that are found on the control manifold. It also has a built-in warning system which lets the driller know if there is any deviation from the normal accumulator pressure or if there is a low fluid level in the mixing side of the reservoir tank. The mini remote panel serves as an additional backup control station should there be an occurrence which disables the driller's panel. The electrical supply for the entire system is fed from the electric power pack. The Kumi BOP system runs off of 120-volt DC power as opposed to AC. The electric power pack converts rig power to 120-volt DC to supply the proper current to the various components that require electrical power. This unit also contains a series of batteries which are continuously trickle-charged by the rig's power. These batteries are capable of operating the system for up to 72 hours on a standby basis in the event of a rig power failure requiring their use. Before we go any further, let's check to make sure you understand the information we've covered. Turn to page 3 in your workbook. Here you will see your first self-check. There are 7 questions for you to answer. When you hear the tone, press the pause key to stop the playback unit. When you have finished answering the questions, press the pause key again to restart the program, and we will discuss your answers. Ready? Press the pause key when you hear the tone. Now, let's check your answers. If you could not answer some of the questions, write them in when we give you the correct answer. If you have answered some of them wrong, change your answer to the correct answer we give you. These will be valuable notes for you to study before taking the test at the end of the program. The answer to number 1 is accumulators. Number 2 is C. Only nitrogen should be used to pre-charge accumulator bottles. Number 3 is pumps. Remember, there is an electric triplex pump and standby air pumps to keep the accumulators properly charged. Number 4 is water. Number 5 is filters. These should be cleaned on a regular basis. Number 6 is hydraulic control manifold. That is where pilot control signals originate. Number 7, the power pack also contains a series of batteries for standby use in case of a power failure. Now, let's continue. This is a subsea hose reel with manual control manifold. The hose reels contain the subsea hose lengths which connect to the subsea pods on the BOP stack. They are connected to the hydraulic control manifold by the jumper hose. These reels have an air motor drive system which allows operation in both forward and reverse. Remember, you must not turn the hose reel while the jumper hose is connected to the reel. Turning the hose reel with the jumper cable connected could cut the jumper cable and damage the junction box on the reel. Always make certain that the jumper hose is disconnected before turning the hose reel. After disconnecting a jumper hose, never lay it on the floor where the fittings will get dirty and can be damaged. Always hang it over something to support it. The hydraulic system may not work properly if the hose fittings are allowed to get dirty or damaged. The hose reels contain a hose reel manifold that is operated by pressure supplied through the shaft of the reel. Prior to disconnecting the jumper hose, you should check to make certain that all of these controls are in the center or neutral position. Failure to center these controls before disconnecting the jumper hose will result in damage to the system. Always make certain these controls are centered prior to disconnection. The subsea hose bundles guide over a sheave and are connected to the subsea control pods. These pods contain the subsea control elements of the system. There are 2 pods on each BOP stack. Each contains a male and female section. The male section of the control pod houses the subsea pilot valves, regulators, and packer seals which are critical to the operation of the BOP unit. This section can be retrieved to the surface for maintenance by means of a wireline air winch. The female section of the control pod is actually in 2 parts. The upper female and the lower female. The upper female is mounted on the riser section and fits into the lower female, which is mounted on the lower section of the BOP stack. This allows the male control pod to be mounted on the riser section without the need for individual stabs and jumper hoses between the upper and lower sections of the BOP stack. The key to this design is a unique seal called the Kumi Packer seal. This seal design is based on the Packer rubber principle, which allows the fluid pressure to assist in the sealing off of the various parts as the pressure is applied. Because the sealing surface provided by each Packer element is relatively large, it will seal under adverse conditions and will not extrude or leak. The BOP stack is the large control that sits on the sea bottom and houses the various functions that are performed. In addition to those on the surface, the BOP stack also houses a series of accumulators. These accumulators allow pressure to be maintained at all times for the operation of the preventers. This also provides for faster operation of the preventers during emergency conditions. These stack accumulators should be checked each time the unit is brought to the surface to ensure that they have the correct charge and are in proper operating condition. Before we conclude the program, let's take another self-check to make sure you understand the material we have covered. Turn to page 4 in your workbook. When you hear the tone, press the pause key to stop the playback unit and answer the questions on page 4. How did you do? Let's check your answers and find out. You should have answered number 8 with the words hose reels. For number 9, you should have answered the hose reels are connected to the hydraulic control system by the hydraulic jumper hoses. Number 10 is true. For number 11, you should have checked A, shiv. Number 12 is control pod. For number 13, the answer is B. For number 14, you should have used the word packer. That is the name of the seal used in connecting the pod connections. And for number 15, you should have answered stack. That is the name normally given to the large control unit that sits on the ocean bottom. Now, let's continue. There are several design features and principles regarding CUMI BOPs that you should be familiar with. First, all CUMI units are designed for 150% hydraulic fluid capacity. This allows for enough reserve hydraulic energy to be stored in the accumulators to perform vital stack functions should there be a total power failure on the rig. For example, if there should be a total loss of electricity on the rig, the reserve capacity in the accumulators would allow the stack to close the well, open it, and then close it again without the benefit of rig power. Secondly, all CUMI BOP systems operate on the principle of redundancy. By redundancy, we mean that each function on the BOP stack can be controlled from 2 separate sources. For example, if there is a malfunction in one of the subsea control pods while a preventer is being closed, the other pod can immediately be switched into line and take over the closing of the preventer. The disabled pod can then be brought to the surface for repairs while the standby pod continues to operate the stack on a normal basis. This redundancy principle can reduce non-drilling time to a minimum. The CUMI BOP stack is basically operated by a pilot signal hydraulic control system. More simply, the various valves that control the main flow of fluid through the stack are opened and closed by means of a hydraulic pilot signal. This pilot system is a closed or recirculating hydraulic system. The main hydraulic fluid that flows through the valves and actually opens and closes the preventers is basically an open-end system. This means that the hydraulic fluid does not recirculate after use, but is vented to sea after passing through the system. Because it vents to sea, you can easily see the necessity for using non-pollutant hydraulic fluid. The SPM valves that actually control the main fluid flow are located in the subsea pods. They are in 2 sizes. 1 inch for main control functions and 3/4 inch for lesser functions. A SPM valve is a spring-loaded valve which is normally in a closed position. To open the SPM valve, hydraulic pilot signal pressure is sent to it. This pilot signal pressure opens the valve and allows the primary supply of pressurized fluid to flow through the valve's bottom port and to the specific function that it controls. At the same time, this pilot pressure is relieved on another SPM valve on the other side of the function. This allows the back pressure to vent to sea. Once the function is performed, the pilot pressure is relieved and the valves are automatically closed by the spring load.